going to the first topic, that is some basic concepts of chemistry. Have you ever wondered how medicines cure illnesses, or how the food in our body converts into energy, or how fuels help in driving vehicles? The answer to all these and similar questions is a single word, that is nothing but chemistry. So, what is this chemistry? Chemistry is nothing but it is the branch of science that mainly deals with the composition, structure, properties of matter and changes that matter undergoes. I repeat, chemistry is nothing but it is the branch of science that deals with the composition, structure, properties of matter and various changes that matter undergoes. So the question which arises over here is, what is matter? So let us define this matter. Matter is the first topic under the chapter Some Basic Concepts of Chemistry. Matter can be anything that has mass and occupies space. So the definition for matter goes like this. Matter can be anything which has mass and occupies space is called matter. Or we can also say that matter can be anything that occupies space, that possesses mass and that which can be felt by any one or more of our senses. These are the various examples of matter: hat, table, computer, tree house, rain, fog, steam, etc. So basically whatever we see, whatever we feel around us is nothing but matter. Before we learn more about matter, it is important that we know the importance of chemistry in our day-to-day life. This chemistry is interlinked with other branches of science like physics, biology, medicine, astronomy, biochemistry, math, etc. And chemistry plays an important role in our day-to-day life. How important is this chemistry in our daily life? So let us now look at importance of chemistry. Chemistry plays a major role in identifying the weather patterns. Chemical industries manufacturing fertilizers, polymers, salts, detergents, metals, dyes, drugs, soap, etc. contribute in a big way to the national economy. Chemistry also plays an important role in meeting human needs for food, healthcare products and other materials aimed at improving the quality of life. So let us now look at the classification of matter. So what is matter? Matter can be anything which occupies space, which has mass. So matter is broadly classified into two types: physical classification and chemical classification. Let us study one by one. Going to physical classification of matter. Based on the arrangement of the constituent particles, Matter can exist in three physical states, that is solid, liquid and gases. Let us now look at the description of each state along with their characteristics. Going to solid state. In solid state, the particles are held very close to each other in an orderly fashion, which means that the particles are tightly packed. Therefore, there is no much freedom of movement. These solids are said to have definite volume as well as definite shape. If we go to the second classification, that is liquids, in liquids the particles are not as tightly packed as in solids. They are loosely held together, which means that they can just move around themselves. They cannot move wherever they want, but they can just move around themselves. So these liquids are said to have definite volume, but they do not have definite shape. Why they do not have definite shape? It is because if we take water or any liquid in a bucket, glass or any other vessel, liquid or water will acquire or it will attain the shape of that bucket, glass, vessel, etc. So liquids do not have definite shape, but they do have definite volume. Going to the third physical classification of matter, that is gases. In gases or in gaseous state, the particles are far apart as compared to those present in liquid state. Just by looking at the image, we can say that the particles, that is the gas particles, are far apart from each other. Their movement is easy and fast. Therefore, gases neither have definite volume nor definite shape, and these gases will occupy the available space in the container in which they are placed. So what we can conclude? We can say that solids will have definite shape as well as definite volume. Liquids, they do not have definite shape, but they have definite volume, whereas gases, they neither have definite shape nor definite volume. And these three states of matter are said to be interconvertible by changing the conditions of pressure or temperature. So what happens over here? Why these three states of matter are said to be interconvertible? It is because solids on heating, what happens? It will melt and it will give rise to liquid, that is solid changes to liquid. Liquids on further heating changes to gas, which means that liquid on further heating, it will evaporates and changes to gaseous state. Similarly, in the reverse process, gases on cooling, they will get changed to liquid, that is gas will condense. Similarly, liquid on further cooling, liquid gets changed to solid, which means that liquid will freeze. Therefore, we can say that the three physical states of matter are said to be interconvertible. So, we are done with physical classification of matter. Going to chemical classification of matter. Matter can be classified as pure substance and mixture based on the chemical composition. So what is this pure substance? Substances which contain only one kind of atoms or molecules are called as pure substance. I repeat, substances which contain only one kind of atoms or molecules are called pure substance. And in a pure substance, the composition of a substance is said to be constant. It is said to be fixed. The composition in case of pure substance is said to be fixed. For example, carbon dioxide. Carbon dioxide is a pure substance which consists of only molecules of carbon dioxide, and it has carbon and oxygen in a fixed ratio. Another example for pure substance is glucose. We know that glucose contains carbon, hydrogen as well as oxygen in a fixed ratio. And the constituents of pure substances cannot be separated. The constituents of pure substances cannot be separated. So let us now look at the another classification, that is nothing but mixture. So what are these mixture? Mixtures are nothing but when elements or compounds are mixed together in any proportion, it results in the formation of mixture. When elements or compounds are mixed together in any proportion, it results in the formation of mixture. Thus, in a mixture, the composition varies. For example, seawater. Seawater is an example for mixture. This seawater, it mainly comprises of dissolved salts, various salts as well as water. So it is a mixture. Seawater is nothing but it is a mixture of various dissolved salts and water. One more example you can give is sugar solution. Sugar solution is nothing but it is the mixture of sugar and water. So these are the chemical classification of matter. Pure substance as well as mixture is further subdivided into two types. Pure substance is further subdivided as element and compound. So let us see what is this element and compound. Elements are nothing but substances which consist of only one kind of atoms are called as elements. For example, sodium, copper, silver, hydrogen, oxygen, etc. All these contain atoms of only one type. For example, if you consider sodium, sodium element is a pure substance which contains only one kind of particle, that is nothing but sodium element itself. Atoms of the same element will combine together in order to form a molecule. What did I say? Atoms of the same element combine together in order to form molecule. For example, an atom of hydrogen will combine with another atom of hydrogen in order to form H2. That is, a molecule is being formed. So atoms of the same element will combine together in order to form molecule. So let us now look at the compound. So what is this compound? How compounds are formed? Two or more atoms of different elements combine together in a fixed ratio and give rise to compounds. So how compounds are formed? Compounds are nothing but these are the pure substances when two or more atoms of different elements combine together in a fixed ratio. Example for compounds are ammonia, NH3, water, H2O. A compound cannot be further separated into its constituents by physical means but can be separated by chemical methods. And the properties of a compound are said to be different from its constituent elements. I repeat, properties of a compound are said to be different from its constituent elements. For example, we know that hydrogen and oxygen are nothing but gases. Hydrogen gas as well as oxygen gas will combine together and they form water, H2O. Hydrogen and oxygen are gases, whereas H2O is nothing but liquid. So properties of a compound are said to be different from the constituent elements. So this is all about compounds. Going to mixture. Once again, mixture is classified into two types, that is nothing but homogeneous mixture and heterogeneous mixture. Let us look one by one. So what is this homogeneous mixture? If the particles are distributed uniformly throughout the solution, then it is a homogeneous mixture. If the particles are distributed uniformly throughout the solution, then it is a homogeneous mixture. For example, sugar solution. Sugar solution is a homogeneous mixture because sugar particles get distributed uniformly throughout the solution. And what is heterogeneous mixture? If the particles are not distributed uniformly throughout the solution, then it is a heterogeneous mixture. If the particles are not distributed uniformly throughout the solution, then it is a heterogeneous mixture. For example, sand dissolved in water. Sand dissolved in water is said to be a heterogeneous mixture. Why? It is because sand particles are not uniformly distributed throughout the solution. And the components of a mixture can be separated by physical methods such as hand picking, crystallization, distillation, etc. So the components of the mixture, how we can separate them? They can be separated by physical methods like hand picking, crystallization process, distillation, etc. We now understood that matter can be anything which has mass and occupies space. Every substance is made up of matter and is said to have unique properties. Therefore, we can classify properties as physical properties as well as chemical properties. So let us look what are the physical properties of matter. Imagine that we have a rubber ball. Let's see how we can describe it. By looking at and feeling the rubber ball, we can say that the ball is solid, shape is round, ball is yellow in color, it smells like rubber and it bounces. Now let's observe this block of sulfur. Just by looking or observing this block of sulfur, we can say that sulfur is yellow solid crystal and is said to have strong odor. What we saw are the physical properties of rubber ball and sulfur. So, how can we define physical properties of matter? So, the definition for physical properties of matter goes like this. Physical properties are those properties that can be measured or observed without changing the identity or composition of the substance. I repeat, the properties which can be measured or observed without changing the identity or composition of the substance. So, these are the physical properties. These physical properties will help us to describe the substance. However, the description is not sufficient to identify a substance. Therefore, it is necessary to also know the chemical properties of a substance. So, we are done with physical properties of matter. So, now let us look into chemical properties of matter. So, what are the chemical properties? So, chemical properties of a substance can be observed only when a substance has undergone certain chemical changes. See, what did I say for physical properties? Physical properties are nothing but these are the properties which can be observed or measured without changing the identity or composition of the substance. Whereas chemical properties, when can we observe? Chemical properties of a substance can be observed only when a substance has undergone certain chemical changes. Example for chemical properties are flammability, reactivity to an acid, reactivity to water, etc. So, the next topic is measurement. A quantitative measurement comprises of a numerical value and a unit. It is shown in the figure, numerical value as well as unit. The units of measurement are derived from two systems, that is nothing but English system and metric system. These are the two systems for measurement. In the year 1960, the metric system was improved at the General Conference of Weights and Measures to create a new system called the International System of Units, or SI. SI is nothing but it is the short form of System International. So, this SI unit pertains to 7 fundamental scientific quantities. They are length, SI unit for length is meter, mass, SI unit for mass is kilogram, time, second, electric current which is measured as ampere, thermodynamic temperature which is measured as Kelvin, amount of substance, SI unit is mole, luminous intensity, SI unit is candela. So, these are the 7 fundamental quantities. So, now let us look in detail at some common quantitative measurements that we will come across. These are mass and weight, volume, density and temperature. So, let us look in detail at these common quantitative measurements. First, let's see what is this mass and weight. Is mass the same as weight? Most of the times, people consider mass and weight to be the same things. However, that is not the case. So, what is mass and what is weight? Mass is nothing but it is the amount of matter present in a substance, whereas weight is the gravitational force exerted on a substance. The mass of a substance is said to be constant, whereas weight will vary or it will differ from place to place due to gravity. For example, you might weigh 100 pounds on earth, but if you go to space, you might be weightless, which means that weight will changes from place to place, whereas mass of the substance is said to be always constant. Mass can be accurately measured with the help of analytical balance, and the SI unit of mass is kilogram, that is nothing but kg. Kilogram is the SI unit of mass. So, therefore, we have understood that mass and weight, they are not same. Mass is the amount of matter present in a substance, whereas weight is the gravitational force exerted on a substance. Let us go to the another quantity, that is nothing but volume. The base SI unit of volume is cubic meter or meter cube. So, what is the SI unit of volume? SI unit of volume is cubic meter or meter cube. Smaller units such as cubic centimeter, that is cm cube, are frequently used in chemistry. 1 cm cube, that is 1 cubic centimeter, is equal to 1 milliliter. Some of the another unit of volume that is commonly used is liter. 1 liter equals 1 cubic decimeter or 1000 cubic centimeter. I repeat, 1 liter equals 1 cubic decimeter, which is equal to 1000 cubic centimeter. Some of the common devices used to measure the volume of liquids are graduated cylinder, burette, pipette, etc. So, we are done with 3 quantities. They are mass and weight, volume. Going to the next quantity, that is nothing but density. So, what is this density? Density is the amount of mass per unit volume of the substance, and the SI unit of density is nothing but SI unit of mass divided by SI unit of volume. Already we have studied the SI unit of mass, that is kg, kilogram, and SI unit of volume is also been studied, that is cubic meter. So, kg by meter cube, we can also write it as kgm to the power minus 3. So, the formula for density is density is equal to mass by volume. The unit, that is kg per meter cube, is said to be large. Therefore, chemists often express density in grams per cubic centimeter, that is gram per cm cube, where mass is expressed in grams and volume is expressed in cubic centimeter. So, this is all about density. Going to the last quantity, that is nothing but temperature. There are three scales to measure temperature, that is Celsius, Kelvin and Fahrenheit scale. The SI unit of temperature is said to be Kelvin. It is not Celsius or Fahrenheit, but the SI unit is said to be Kelvin. The thermometer with Celsius scale is calibrated from 0 degrees Celsius to 100 degrees Celsius, where 0 degrees Celsius is the freezing point of water, whereas 100 degrees Celsius is the boiling point of water. Similarly, the Fahrenheit scale is represented between 32 degree Fahrenheit to 212 degree Fahrenheit. The temperature on Celsius scale and Fahrenheit scales are related to each other by the relationship, that is degree Fahrenheit is equal to 9/5 degrees Celsius plus 32. I repeat, the temperature on Celsius and Fahrenheit scale are represented by this particular relationship, that is degree Fahrenheit is equal to 9/5 degrees Celsius plus 32. And also the Kelvin scale is also related to the Celsius scale, as Kelvin is equal to degree Celsius plus 273.15. So Kelvin and Celsius scale are also related to each other by the relationship Kelvin is equal to degree Celsius plus 273.15.